Adra, who are the leaders for the Enhance International Group and Creatosoft, respectively. And I'm very excited to have them with us. Jim developed and refined digital workforce resilient enterprise ecosystems throughout his career to accelerate innovation, leadership development, strategy execution, and value creation globally. He has served as a resilient enterprise executive leader and advisor for companies from startups to Fortune 50. He oversees the global identification, prioritization, and execution of high-value business improvements and innovations for companies, business partners, and customers in multiple markets. He has held operational excellence, sales and supply chain, and sales leadership positions in leading global companies in the chemicals industry with Air Products and Chemicals, energy with General Electric Energy, security with Tyco ADT, and supply chain with C.H. Robinson. He believes that people make the difference, and it is in harnessing people's talents that company can become resilient. Joining Jim, we have Hosni Adra, who is the co-founder of Creatosoft and has been involved in process improvement and simulation for the past 30 years. As the holder of several patents in the fields of dynamic simulation, digital twin technology, and tracking, Hosni has been a sought-after expert in these fields and has presented multiple papers on process improvement using simulation, digital twin development, and lean concepts implementation. With his dedication to the use of technology to improve efficiency and output, he has positioned Creatosoft as a leader in the data-driven digital twin and process improvement industry. Ladies and gentlemen, it's a true honor to introduce these two great leaders of digital transformation, Hosni and Jim. Thank you for taking the time to sharing your expertise with our global audience today.
Thank you, Jose. It's an honor to be here on this incredible, interesting conference. Good afternoon, good morning, and good evening, wherever you are around the world. Hosni and I are very excited to share with you Unleashing the Digital Twin to accelerate Industry 4.0. Implementing a digital transformation in a streamlined manner is one of the greatest challenges that we have out there today. And with companies' limited resources, speed to implementation, while not negatively affecting the current workflow processes, has always been a challenge for manufacturing operations, logistics, and supply chain. With the advent of the digital twin, Internet of Things, and cloud-based solutions, tracking everything from tooling consumables to the job itself as it winds through the factory has always been a challenge. Again, my name is Jim Vries, founder of Enhance International Group, representing Wisers today, the digital solution to provide you the visibility of consumables, jobs, and tooling with demonstrated return on investment of well in the 6 to 12 month range. Enhance International is a platform of over 50 consultants, consulting companies, and SaaS providers dedicated to empowering your organization's workforce by leveraging EIG's tenured expertise. Our goal is to provide collective, collaborative, experienced thought leadership to enable organizations to deliver self-sustaining, positive margin growth. The competitive advantage focusing on 90-day action plans. We thrive on delivering 1 + 1 + 1 = infinity. EIG is honored to bring together two of our synergistic partners, Creatosoft and Wisers, who are collaborating together on projects to provide customer value. Hosni, a few words.
Good morning, everyone. Good afternoon, good evening from the greatest city, Chicago, Illinois. Thank you all for attending. I'm Hosni Adra with Creatosoft. Started out 30 years ago building a platform to develop digital twin technologies that evolves through industry standards. We have implemented a digital twin that takes you all the way from the visualization aspect all the way to the learning digital twin that we're going to talk about today. All the way from connectivity to current data systems, RTLS, and more. Looking forward to a great presentation and showing you how that digital twin transformation will accelerate your workplace and improve the efficiency of the operation. Jim?
Great, Hosni. So let's get started. First, we'll introduce you to the roadmap to the Industry 4.0 smart manufacturing for environment, from your shop floor to the hospital emergency room to the remote call center. Then we will talk about the digital twin overview, and Hosni will give you the evolution of the digital twin. And then third, Hosni will show the power of CreatorSoft's platform and how quickly it achieves competency in a digital twin. So you can get up and running very quick. And we'll do that through our 30-day plan, 60-day for predictive decision making, and 90 days to real-time prescriptive, and sometimes people like to say learning system process control. So believe it or not, you can do that within 90 days. Very exciting, and we are very interested to hear your feedback. So please, as Jose said earlier, fill up that Q&A chat box and with lots and lots of questions. We look forward to it. So getting started, the following is the 5 steps to improve your business so that you can realize the Industry 4.0 challenge of digital transformation. We will be referring to this roadmap throughout today. First, we have organize, getting our house in order, sort and organize the workplace. Secondly, we have standardize, and we're going to emphasize going through the 5 S's, at least to the standardized level. So we'll show you how to accelerate this process by digitizing it. Thirdly, we get into organized, and in the organize will involve pulling out everything we have, every item, and sorting them into 3 categories: valuable, repurposed, and junk, your non-value added. And then standardize, we will look at the standardize and visualize for that digital transformation. In the visualize stage here, we're going to look about value stream maps. All of Hosni's, when he's on board, and what Wisers does is provide you that value stream map of the data collection and of your work processes. And then we get into the stabilize step, where we operationalize stable operations. This is one of the most challenging steps to achieve and sustain. We believe data to make timely informed decisions. It is impossible to maintain without a stabilized step. So this is one of the most active feedback loops that Hosni will cover in a few minutes. And then finally, we get to optimize. So we always talk about stabilize before optimize. If you try to optimize an unstable process, you're going to have some challenges ahead. So next, we'll just review the 5 S's that everybody is probably pretty familiar with. And again, we're digitizing this. So we'll sort it out, take the inventory, eliminate unnecessary items, set an order, step 2. Step 3 is shine, take total inventory. And this is where we'll leverage Spinwiser's smaller items, but they're high value items with significant cost savings and enhanced tracking. And then in step 4, we get to standardize, establish inventory needs for the shop, adjust as needed, and enhance capability and tracking. And then our final step of sustaining is leveraging the data from the system to control our process so we can be proactive as opposed to reactive. So let's get down to the Gamba. Let's walk the process. So in the workplace, how does it look? Well, the Spinwiser system is on the shop floor. There's totems by the tool crib or in the tool crib. And that system turns all this data of the ingress and egress of the data of your parts, your consumables, in and out, and it tracks them in real time. And then, of course, our benefits from this are that data is generated as a tool. On the tool withdraws, the reports on usage and trend data. You have minute-by-minute inventory level adjustments, and auto reordering is based on those safety stock levels. So how does this fit together from a system perspective? it's pretty cool because you can have a tablet assigned to the floor, or you can have it programmed within a cell phone. And then we start off on the right there with smart locks. So smart locks are used for tooling and consumables that can't be stored on shelves, such as like bandsaws and odd items, belts, cables, all those items are stored there. Secondly, smart lockers can be either created for you, or we can take existing lockers and modify them with locks to track the ingress and egress of all the different parts. And then thirdly, you see the Spinweiser, which is a carousel there that has 5 doors, 75 compartments on this carousel. This is set out on the shop floor, on this beside your CNC machines, tracking tool usage. So again, one of the biggest goals here is, when does a tool need or insert need to be replaced? Well, we're tracking that together with the in and out of the tool in the Spinweisers and the operation of that tool or insert on the actual CNC machine. So we're doing life analysis with that. All that data will be fed into the real-time reporting that Hosni has and Spinweisers together to optimize the tool life of the tooling and of your consumables, so that reorderings are taking place at the right time and you're actually performing, and you don't have degradation in the creation of your products. So that summarizes for you what the Weiser system is. Very inexpensive system, very quick to implement. Everything can be done remotely. We send you the different components, we train you online, and we can have you up and running within a week. With that, we'll go to the next section. Hosni?
All right, hello again, everyone. So what I'm gonna do is cover that digital twin transformation. What's the meaning of a digital twin? What is the transformation? How do you go from the basic digital twin implementation all the way to the full learning integrated digital twin that we all wanna have? So with that, I'm going to go through the 4 digital twin technologies that are available in the market today. Initially, you're going to start with what we call the visual twin. The visual twin is really what it means. It's very visual. It's going to show a lot of detail on how cool the operation is. It's got a huge factor of implementing and showing what the operation is going to look like. So it is really, it's got a great wow factor. It's got the proper implementation of how things will flow through, but it's only visual. Okay, and I will touch on that here in a second. From there, we go to a randomized twin. So when you take that visual twin and you add to it data, and that data is totally randomized data based on the implementation itself, you're going to end up with what we call the randomized twin. It is a good starting implementation to your digital twin technology or digital twin transformation, and it's one way to get to the full learning twin as you go forward. The improvement on that is really to tie in that digital twin that you made, that visual twin that was purely visual, and tie it into actual data. What is happening on the factory floor, what's happening in the hospital, what's happening in a warehouse. So this digital twin now, that's data-driven twin, is going to allow you to actually see more detail on the operation, to be able to actually identify all the constraints that are tying in your efficiency and not allowing you to perform at a much higher efficiency ratio. And then once you get all these things together, that's when you get into the learning twin. The learning data-driven digital twin is going to allow you to achieve what we all want, is a digital twin that reacts and acts based on actual data that's driven by the floor, by whatever events happen on the environment, and allows me to optimize basically on the fly and be able to feed data back into the other systems that are attached to the digital twin technology. So that's really what we want to get to at the end of the presentation, and how to achieve that learning data-driven twin from an implementation point of view. So really the path to get to the data, to the digital twin, to the learning twin, is one, you have to identify what your goal is. Before you do anything, just like with any other implementation, if you don't have a goal in mind and you know where you want to end up, you will basically not complete the project, and it will just be a cool modeling experience that really gets you nowhere. So that's very, very important from an implementation point of view. And then what you want to do is identify your target. What do you really, which twin are you really after? Do you want to get the learning digital twin, or you're only looking at the visuals? So from there, if you're only looking at the visuals, you basically start implementing the visual twin, and that's really the easiest one to implement because it's just purely visual. You can pick up any animation tool that actually will do that and helps you achieve that. Now, a randomized twin has a bit more data into it. It's got time studies into it. It's got some data distributions that are feeding it. So it has a bit more control over what actually goes on. And then from that point, if you want to get to the data-driven twin or the learning twin, you really have to start implementing a different type of data connection and data retrieval that you're going to have from the operation itself. So there are different phases there on how you achieve them, all the way from the starting all the way to achieving the full implementation of the twin, all the way from segmenting the operation, starting with the section that has the most ROI or is the most constraining factor, and expanding from that point forward. And then as a phase two, it's really tying it into that data systems that you have, whether that is an ERP system, an EMR system, a WMS, even an RTLS or a GPS tracking set of systems. So from there, you really get into the benefits. So let's just talk about what you get from each one. A visual twin, as I said, it's purely visual. It has zero analytical power to it, but it's a great way to show people what the operation is going to look like. So if I establish a visual twin, I can basically show people how they walk through the building, where the machines are going to be. I can maybe show the machines operating, but that's all they do. It's just a visual representation of what it is. Now, the randomized twin goes a bit further by applying distributions into the operation. So now those machines, those equipments that I have, those have some cycle times. They might have some downtime associated with them. If I'm using a fork trucks in a warehouse, for example, those fork trucks have some efficiency factor associated with them, speed and so on, but they're all based on a distribution. Okay, it just takes whatever distribution you end up using as the driver for that. So you really get a good enough representation of it, but you really cannot optimize randomized data. You're going to get optimized randomized results. So you have to be very careful with that. When you get to the data-driven twin, now you're actually consuming data that the plant or the warehouse or the hospital, the clinic is actually using. So this is whether it's totes arriving, trucks arriving, machines operating, this is the data that's coming into the twin. And we'll expand on that quite a bit here in a few seconds. But this is really what you need to do to actually do full analysis of what's happening and within the operation itself. That's really the guts of the learning twin. So without having that data-driven twin, you really cannot have a learning digital twin, because the learning twin is going to actually use those events that are built in within the operation, and then at the same time, it's going to take other external events that will feed in. And those are going to be the reactions that will happen within the workplace and how the environment itself is going to be modified. So I'm going to touch on that and mainly the last two options the most as we go through this presentation. Now, keep in mind, this is not industry specific. So you can apply this same concepts to any industry, whether it's a service, whether it's a call center, a bank, a warehouse, a supply chain, a manufacturing place, high mix, low mix, any type of operation is going to fit those criteria. So let's make it real. Let's just go through and actually define all these components and how to implement them. So from there, if you look at the visual twin, I'm just going to go through this very quickly. It's representing a flow. You can look at this thing in virtual reality mode. You can look at it on a full 3D perspective view. Pretty much anything that you want there from a representation point of view. So this is a purely visual representation of the operation. Think about it as an architectural drawing or three-dimensional architectural drawing that allows you to do walkthroughs into the building, or a virtual tour if you're buying a house and you're remote and you want to see what actually happens there. So again, it's got to look cool because that's what it provides, but you cannot get any actions out of it. It's just a visual of the representation itself. That takes us to a randomized twin. And the randomized twin has been very widely used in the industry all the way up to maybe 5-6 years ago. That randomized twin is going to consume data that is randomized from the operation itself. And this is, whatever QA, I've got, 5% rework ratio out of an operation. If you look at it in ED, for example, an emergency department, you've got some arrival rates that you put in based on some distribution that somebody figured it's the way patients arrive to my ED. Trucks arrival at a warehouse. All these are going to be based on a distribution that through time, we decided that that's how often these trucks arrive at my warehouse, and I'm going to build my warehouse based on that distribution itself. So really, to get any results out of it, you have to put in some Monte Carlo simulations there to be able to eliminate that randomness. So every time you do an optimization on that twin, you're really going into the representation of what actually goes on and repeat that process many, many times in order to see if that solution is going to work across all of the different representation of the digital twin and of the solution you're trying to provide. So take it as an example. If you take, everybody will say, oh, my data distribution fits a specific normal distribution with a mean and a standard deviation and all that. And they try to fit the data to a known distribution. Your data is exactly what it is. It's got its own distribution. Your factory floor works in its own way. It may not fit a Gaussian distribution. It may not fit a normal distribution. It might be an nth degree polynomial that fits your distribution. So we cannot just take that data and force it into a known distribution in order to have a digital twin representation. That's going to give us errors and wrong results at the end. So this is really the downside of the randomized twin. It does have the visuals. It does allow us to do some kind of analysis and representation of what actually is going to happen forward, but it's not enough to drive the total digital twin transformation that we're all after. So from there, we go into the data-driven twin. The data-driven twin is going to connect to your ERP system. It's going to consume data from the ERP, from SCADA, from the PLCs, from your WMS. It's really going to get data that's relevant to your floor, to your workspace, and it's going to use that to drive the actual representation of the virtual workspace that you develop. So it also needs to know what is happening today at the plant or at the warehouse. So it does retrieve a current state. Now that current state could be a state that is 2 months old, and you're going to load data that's 2 months old. That's fine. You can do analysis on seasonality based on loading that different data sets. But now you're actually comparing what happens with that exact same data if I did say things differently. Now you're comparing apples to apples, not apples to oranges or apples to grapes. So this is really the advantage of having that data-driven digital twin from a representation point of view. So with that, what we would do is we would actually have the connectivity going in. Each one of these clouds really represent the data stream. And data could flow in and out of that digital twin representation. Everybody assumes that a data-driven digital twin is only consuming data, but in reality, a data-driven twin could actually generate data out, and it can transition itself to a learning twin from that point forward. So with that, you can tie in all the consumables into the data-driven twin. How are the consumables affecting my flow? How often do I change the saw blade? What kind of materials affect more the representation of the flow itself? And then from that point, you can add ergonomics into it. You can see how the movement actually affects your efficiency. If you repeat the movement 50 times in a row, you're not going to be as efficient the first time as you are the last time. So these are all factors that could play into the data-driven twin. So with the representation, if you look at the representation of our data-driven twin, is we actually take initially your system constraints. That's actually what drives the operation itself. This is, whether it's space constraints or other constraints that you have within the operation. Then you're going to get your current state. This is basically loading that digital twin with actual events that represents a true state within the operation itself. You're going to put in all your scheduled maintenance. These are the things that you know. These are the things that I know that this machine is going to go down on. I know that fork truck is going to have a battery charge requirement, or that AGV is going to have some kind of a downtime along the way. The other thing is historical data. Historical data is going to help that digital twin to actually give you that actionable results that you need. And then most important is, what's your schedule? What are you trying to produce? So all that is going to feed in basically to generate that insight into the operation, so you can make decisions on whether how to improve or how to modify in order to be more successful in improving the overall efficiency in any workplace. So from there, we basically tie all these things together, and you basically get a representation of a digital twin that's actually generating data that's related to your operation. It's not randomized data, it's actual data that is a good representation of your flow. So in this environment, you actually get a pretty high accuracy rate from your digital twin representation. You're going to get in the upward of the 99.5% accuracy on how well that digital twin actually is performing. But it is not a learning system. What it is a representation of the current state. It's representation of your plant. It's representation of the current workspace. But it's not going to learn yet and identify what will happen going forward once you make that transition. So we go into the real-time learning twin, and the real-time learning twin actually gets all of the inputs that we have from the data-driven twin. Now, keep in mind, this is not an offline environment that's running. If you want to have a learning digital twin, it has to be a real-time implementation. It has to have to consume events that are actually happening off the floor, so you can have that digital twin learn and provide you feedback on how to improve. So from there, we include what we call the unexpected event. My machine went down. Half of my workforce didn't show up today. The fleet, my 3 AGVs decided not to operate. What do I do? How do I operate the operation? So this is where the learning twin will come in. It will learn from that environment that you give it, that historical representation of how your operation behaves. It has this optimization built into it to actually take those unexpected events, feed them in, and come up with a solution that'll help you move forward. And then from that point, it's going to help you be proactive in the way you operate. You're not just waiting for the problem to happen in order to react to it. Now you know 2 hours from now, there's going to be this event that's going to delay my operation, or based on what's happening now, my orders are going to be 3 hours late. I'm going to miss a truck shipment. So the learning digital twin with its own optimization can now tell you how you can get back on track. And it's all real time, and it's all giving you that feedback within the operation itself. So this is really the advantage when you talk about learning twins. It's not just a visual of the operation of a random or a randomized system. It's a true representation of what actually is happening within the operation itself. So it's going to take all of these constraints and it's going to play them in an optimized environment, whether that's going to provide you work instructions to the floor, whether that's going to give you an optimized schedule of work that will be modified. You know, that the actual sequence of releases into the shop could vary. The actual releases into your pick environment could vary. So all these will actually be updated dynamically from the learning digital twin. And then from that point, you can actually take that and drive it back into your existing systems. So from there, you basically get into this really cool slide that really takes the demand driven and tie it in together with the SNOP and the demand driven of the operation, and take it all the way from the consumer to the manufacturing implementation or to the actual operation itself. So it's all driven by market demand on one side. You have your scheduled implementation that's are actually being implemented, and that digital twin is helping you achieve the demand that's required without having too much inefficiencies within the operation. You don't want to just over exceed your demand and increase your WIP along the way. You don't want to spend too much money achieving the operation itself. And that's really where the digital twin, the learning digital twin, I should say, is going to help a lot from a digital transformation page.
And
Now,
we
from there,
we want to thank the Demand Driven Institute for that slide.
Yes, absolutely. Absolutely. Thank you, Jim. So from there, just some sample dashboards that actually come out from the system. Now, these are all customizable. We just pulled some just to give you an idea of what you can have. One is looking into the operation and saying, this is what my standard should be, and this is where I am with that specific operation. So how far am I from the standard, and would I be close to the standard going forward based on how things are progressing, or am I going to be behind? Another one is pulling data from the PLCs, and then it's actually capturing that data and figuring out, based on the type of material I'm actually working on, the saw blade, as an example, is going to be replaced sooner than I expected because of the material that actually went through. So that's something that's unexpected. Although it is a scheduled maintenance, now that scheduled maintenance is going to be moved up, because otherwise you're going to generate products that are not up to the quality standards that you need. So it's all working in advance. It's proactively looking into the operation in order to minimize any efficiency or quality control that will happen downstream from there. Now, also the learning twin could give you work instructions at the individual floor. And now you don't have to have, the workforce could vary. You can drive the worker at this point to say, this is the next step that I want you to achieve. As they're going through it, you can implement steps in the learning twin to actually feed back and identify to the worker that they're performing the operation correctly, they're not performing up to they need to change, or they're doing things wrong, as you would see in this case. They're putting the pallet in the wrong location. So this is all driven by data that's coming in real time, feeding back into the operation, and only when that completes and completes successfully, I'm going to give that operator another task to do. So now they don't have to think. I've got the system helping me identify what is the optimum way to run my operation, all in real time, all through constant optimization of the system itself. So you've got that repeated analysis that's happening in the background of the operation, no matter how large it is, no matter how large your operation is in the background, it will actually run and it'll give you the results in real time. It's going to retrieve all the data, it's going to have all the historicals, and it's going to allow you to do whether manpower allocation, figuring out your schedules, all different components that are required to run efficiently. And it's all driven, there is a built-in neural network that we have used that actually learns from the implementation itself, and it's very adaptive to different implementation. with very fast turnaround rate. And Jim will actually take us through the transformation and the implementation phase of the digital twin.
And just before we do that, I know we're running short on time, but I want to cover these benefits that are ringing through here that we've discussed. You know, the flexibility to building customized reports to meet executive, to middle management, to frontline reporting, to actions on the floor. All this data is tied together in real time, giving you that real-time optimized work instructions. And we're going to minimize surprise events with a clear understanding of where those bottlenecks are as they're occurring throughout the day. So it's not like I ran it today and then found out the bottlenecks of yesterday. It's actually optimizing as the bottlenecks are coming up throughout the day. And of course, management has complete visibility and control of operations. They can see how they can help enable the workforce. Again, we're very big proponents of people first. Let's give the power to the people. And then, of course, there's a very high ROI of that is just incredible when you see all the case studies that we have, easily less than 3 months, at the most 6 months on any of the implementations. With that, we'll just go to the house slide and close it out with our 30, 60, and 90-day plan. We'll skip through this so we can get some Q&A in here. So the house of quality there, or the house of quality, the house of digital, data-driven digital twin on the next slide, Hosni, we'll cover where we, you know, in week 1, we'll do the assessment. Week 2 through 4, we'll pilot. 5 to 6, we'll implement, and 7 to 9, we'll integrate, and then we'll optimize. So we're able to do that very quickly, following the Wisers and the Creatosoft's methodologies, integrating these two great technologies together to provide you, the worker, everyone, the power to make decisions. And with that, we're going to close it out for the presentation and go back to Jose.
Terrific, Jim. Terrific, Hosni. Thank you for the presentation. What a great demonstration of how we're translating the principles into action, how you're leveraging the technology for the digital twins and creating value. I'm going to ask you, Hosni, if you could please stop showing your presentation screen to the audience so that we can come back on the larger screen with everyone. Great presentation I have from Jim and Hosni, from Franklin De Souza here, and a lot of other presentations. So I'm going to ask you for the following quick fire Q&A here, because I want to cover as many of these questions as possible. So I know any one of these topics we can spend the next 5 hours talking about it, because it's so interesting. There is much more to be covered, I am sure. So the first question that I have is that you have shown here a manufacturing example. And I'm curious, and the audience is curious as well, is that could this be applicable to transactional processes? If I'm doing banking processes, if I'm doing insurance processes, if I am doing transactional processes, could this concept that you share here in a manufacturing environment be also applicable to a transactional process? Hosni, you are muted, I think.
Yes, I am. Absolutely. You actually can apply the same technology to any industry, whether it's a transactional operation, it is a call center, it's a bank, or it's a warehouse and a supply chain. So it's the same methodology, just different steps, different implementation factors that play in.
Yeah, I would just build on that, is that a lot of optimization engines are only discrete event, meaning events that happen one by one. Some are continuous, like big production facilities, and there are very few people who know how to combine both discrete and continuous flows and then optimize on them. The Creatosoft system is able to do that.
That's an important distinction. Thanks for noting that. Now, another question that came up is that, you know, as you see the evolution of digital twins, And you did a really nice job of showing you kind of just the wow factor of what it reminds me of old process mapping, right? People map their process, say, wow, look at all that process, and then they don't do anything about it. And now you're talking about a digital version of those things. And this first level is the same, it's the wow factor, and then you progressively get more and more value out of it. Now, as you progress, you obviously need a lot more collaboration among different functions in the organization to make this work. So the question is about governance and who should lead this. How do you structure a team to tackle this in the most effective way?
So that's going to vary based on the organization and where they are with the digital transformation. And the level of involvement they will have is going to be different. Normally, there will be a team we collaborate with the client at that point, with the company. We set up the main point of contact, and depending on the implementation itself, we're going to get the data from the client at that point retrieved in order to identify all these points that they need to be done. We agree on the goals and the progressions and how it's going to progress, and then basically move forward. It moves pretty quickly once we get started. So there will be some involvement definitely from the company that they have to put in. They know their processes more than anybody else, so that's very key.
I want to get a little bit more specific on this. So who should lead from the client side to make sure that this works well?
So it's going to be somebody who is on a management side, who can understand the operation in detail and be able to basically transition to the workers, because they're going to be affected too, and to upper management in order to see the benefits.
Yeah, so from a plant perspective, it's going to be your plant manager, and then the area. A plant may be split up into 4 or 5 areas, so you would choose maybe one of the cells as a pilot and focus on one of those cells first and get them up and running, go to the next cell, and then the next cell, and the next cell, if there are 4 cells.
I'm glad you mentioned that, Jim. Thanks for that answer, Hosni, and thank you for that follow-up, Jim, because the next question was about that. What is the best way to get something like this started? So a couple of very important things you said there. You never said that IT leads this initiative for the client, and because I think that your experience shows that that's not the most effective way of getting these things implemented. You're looking for leadership with deep operational insight, and then IT collaborating from the technological side. I do have a question related on the technology side. This comes from William Fuller in Oregon, and he's asking as how are these communications taking place? Is this like through Wi-Fi systems in the plant? I mean, what type of kind of communication protocols you leverage? Curious about how do you make this pieces of equipment all talk to each other? What do you see as the most kind of effective technologies out there that make it happen?
So from the connectivity point of view, we're going to use the existing infrastructure that exists in the plant. Most of them have pretty robust systems that either wired or wireless. There is a drive to get to the 5G implementation on a Wi-Fi system. So these are other things that could also improve the connectivity to the Wi-Fi network. Wi-Fi is evolving, and as it evolves, we're going to leverage more its availability, because it's going to make us easier to roll out than to have to run cables everywhere. We need to have a connectivity.
Very well. I have Stephen Parker here losing his mind online saying, hey, this is really great stuff, great examples here. But the question is, this is not easy to do. Who is implementing learning digital twins today? And it's in their factories or in their transactional processes today. And yes, they get a good ROI, but what we're talking about here in terms of ROI, is this like a few $1,000s, hundreds of thousands, millions? What if you have a specific example that you can show, that you can talk about, that shows the return that they actually had in this investment?
So I can share a very quick one. A warehouse implementation, for example, achieved within a 3-month cycle. The project was paid off, and their ROI was about $750,000 return on investment after that 3-month cycle. So just to give you an idea, not all of them are going to be as big, but they're definitely there. There's huge improvement that you can get out of these. The range is that within 2 to 3 months, the project will pay for itself.
Yeah, so
That
the
is
pricing,
fantastic. Go ahead,
yeah, and
Jim.
the pricing ranges in the order of 50 to $250,000 to maybe a little bit more, but it's not real expensive to get up and running. Hosni, any added comments there?
I mean, exactly. I mean, we're talking about 3 months implementation. That's going to pay for itself as soon as we're done. You're going to start seeing the ROI for the system. You don't have to wait 3 years to pay for it. You're going to pay. It's going to pay for itself right away. You know, we've implemented it in smart building technologies, and the smart building actually got a 4 months ROI. Within 4 months, the energy saving paid for the system. So that it just gives you an idea.
Terrific examples, gentlemen. We're out of time right now, but I want to thank you so much for a terrific presentation and great answers to the questions and to the audience as well. I mean, there are other questions we couldn't get to. Jim and Hosni, what is the best way of getting hold of you and learning more about the implementation of digital twins?
You can contact Hosni or myself. I'm at jdevries@consultingeig.com, and Hosni's at
Hosni.adra@creativesoft.com.
Fantastic, gentlemen. Jim and Hosni, thank you so much for sharing your expertise on digital twins that create value, and we're all very grateful for that. Thank you.
Thank you everyone. Bye-bye.
Bye.
Bye-bye, ladies and gentlemen. That was Jim Vries and Hosni Adra. A great presentation on digital twins for value creation, the different levels of maturity that you go on the digital transformation journey. Again, in a manufacturing setting, but also readily applicable to transactional processes across industries as well. So terrific presentation. We're going to wrap up now, and we're going to come back at the top of the hour with an awesome leader of digital transformation directly from Israel. And I'm talking about Dolly Sharitif, who is with Teva Pharmaceuticals. She's going to talk about transforming the way we work in the digital era. So I'm looking forward to her presentation. We're going to take a break now, and we'll open the session back up at the top of the hour. Thank you again for your terrific engagement in this first session.